Hello, mathematicians. Today we are going to work on explaining equivalent fractions. This is lesson 27 in your Learn book and in your Learn lessons. So eventually you're going to need your Learn book and a pencil. So if you want to pause and get that, you can. All right, so today you can see that I have drawn 3 rectangles, and each rectangle represents a hole. So I have, 1 hole, 2 holes, 3 holes shown for you here. How can we double the number of units? Actually, hold on. First, I'm going to split them into thirds. Forgot to do that. So if I want to split my hole into 3 parts, I could do it lots of ways, but I'm going to choose to do it this way today. So let's just call this rectangle A and B and C. Now back to my question. How can we double the number of units in the second rectangle, in rectangle B? So if we have thirds in A, how can we double the number of units for B? Well, we could split this. We could split each part so that it has 2 times as many. I'll just make one line down there. Now I've split the units. I've doubled the units. And what is my unit fraction now? What is my unit fraction now? It is sixths because I have my whole partitioned into 6 parts. All right, so hopefully that's not too hard. I have doubled the number of parts of units in my second rectangle. Okay, so what about this third rectangle? I want to triple the number of units in rectangle C compared to A. I want to have 3 times as many units in C as in A. Triple the number of units in this rectangle. Well, if this was worth 1 unit, if I want 3 times as many, I would be splitting it twice, which gives me 3 parts. And then I would continue to do that for each of the segments. So now what is my unit fraction? It's ninths. I have 9 parts shown here. And that is 3 times as many parts as in rectangle A. So this is the first step. I just wanted to split these rectangles up in different ways with a different unit fraction. And now comes the hard part, where we start to talk about or explain equivalency. You're going to need to explain it in your answers in your workbook today. And I know that a lot of you are good at drawing the fractions or finding the answer, but we all would probably agree that explaining it is the hard part. So I'm going to help you, guide you through some conversations as well as I can on a video, and I'll do some of the problems with you to help you see some explanations that you could maybe use when you're thinking about your fractions. So first, let's talk about what we've done here. They all started out as thirds. They all started like this, but then we cut them into different parts. The parts are different sizes. The size of one of my ninths, the size is smaller than a sixth, and it's smaller than a third. And so they are different sizes and they are different units, but something is the same, and that is the size or the value of the whole. When I split my rectangles into different sizes, I never changed the value of the whole thing, did I? Each of these still has the same value, or the same size, or the same worth. I just changed the number and size of units on the inside of the whole. So some things that are worth talking about over and over every time you do fractions in third grade is just this weird truth that a third, even though a 3 is a smaller number, the third is the biggest size of all when we were comparing the unit fractions. Third is bigger than a sixth and bigger than a ninth. And that's just so weird when you're starting to learn about fractions in third grade and second grade. Because for your whole life, 9 was bigger than 3. But 1/9 means the whole is split into 9 parts, and they are smaller than when the whole is cut into 3 parts. So I just wanted to talk about that. Whoops, let me make sure you can see these. I'm sorry. Wanted to make sure we just made mention of that. When the whole is cut into more pieces, the parts or the pieces are smaller in size. You might find yourself writing something like that in your answers today. So the more I cut or split, the smaller the pieces got. Okay, I'm going to jump into the Learn book. So you will be on page 167. And I'm sorry, yesterday I think I typed the wrong page number in your assignment, but I hope you figured it out. So today, I think you're going to think, like this first part, it's not too hard because they drew these beautiful fraction models for you. It says use the pictures to model equivalent fractions, fill in the blanks, and answer the questions. Okay, so they did this drawing for you. It says 4/6 is equal to how many thirds? Well, here are my sixths. And they want to know if you have 4/6, how many thirds does it equal? And they drew it and lined it up beautifully for you so you can see it. Here are my thirds, because my whole is in 3 parts. My whole is in 6 parts. So I can see that it's equal to 2/3. 4/6 equals 2/3. So that part is actually a review. You've done that before. What we didn't make you do before is explain it. So now they're going to start to ask you some questions and have you put it into your own words. What happened to the size of the equal parts when there were fewer equal parts? Well, let's just start by saying, well, which one has fewer? Okay, well, this has 4 parts and this has 2 parts. So we're saying that this strip, this fraction strip, this model has fewer parts than that one. So what happened to them? When there are fewer parts, they're actually bigger, aren't they? So we could say that. What happened to the size? They are bigger. And then what happens to the number of equal parts when the equal parts became larger? When the number of equal parts became larger. So they're not saying which part is larger. They're saying what happens to the number of equal parts when they become larger. Well, the number of equal parts that is larger is up here. So what happens to them when there are more parts? I'll write that up there. Maybe that'll help you. So it's not the size is larger, but the amount is larger. Well, when the amount is larger, the parts are smaller. I wanted to take time on this because I'm recognizing that you might be confused. This is fewer parts, but they are larger. There are more parts, there are a larger amount of parts, but they are smaller than. So I hope that you might want to, I don't know, take your time on that and make sure that it makes sense to you. So I'll do this one and ask you to finish that one. Now let's go down to number 2. I did want to take some time to do this one with you. Okay, 6 friends want to share 3 chocolate bars that are all the same size, which are represented by the 3 rectangles below. When the bars are unwrapped, the friends notice that the first chocolate bar is cut into 2 equal parts. The second is cut into 4 equal parts, and the third is cut into 6 equal parts. How can 6 friends share the chocolate bars equally without breaking any of the pieces? Without breaking any of the parts. Well, first I'm going to just start by cutting my candy bars here. That one had 2 parts. This one has 4. I like this problem. It's about candy bars. And it's true, candy bars do come in different cuts, don't they? Like Almond Joy says, 1 on each side of the package. And, Hershey bars have all kinds of cracks and crevices. So let's see, 6 equal parts. Okay, well, I'll do the half. And then I'll make 3 on this side. And 3 on this side. Okay, so I have my 3 candy bars cut into parts. Then what? 6 friends want to share them equally without breaking these partitions up. So this means, they're going to split the candy bars, but only on the cuts that come from the manufacturer. They're not going to take their knives and cut these up smaller. So let's see. You could do this in a couple different ways. I'm going to start with a way that many kids think of. They draw 6 friends, and I'm not going to do the whole 6 people for each of them. Here's my friends. I'll just do smiley faces. There's 3 friends, 4, 5, 6. Okay, so everybody's happy because they're getting candy. All right, well, let's start with what our eyes can see. We have 6 friends who want to share these candy bars. 3 candy bars, 6 friends. If I split my candy bars in half, can't I give each friend a half? 1 friend, 2 friends, 3 friends, 4 friends, 5 friends, 6 friends. Your eyes should tell you, because of the model you can see, yeah. So I'm going to do a line. This is what a lot of kids do when I ask them to do this problem. This friend gets this half. This friend is getting that half. This friend, I guess this friend is going to get, I'll write their fraction next to him. This friend here is going to get 2/4. And this friend is going to get 2/4. This friend is going to get how much? 3/6. And this friend will get the last 3/6. So this is one way to see the math. And I would be proud of any kid who did it this way, who visualized the story problem and literally passed out with a drawing half of a candy bar to each friend. But what you're seeing is that there are many ways to represent a half. It could be 2/4 in this case. It could be 6. I know there are candy bars where the pieces are cut into 8 parts. So if we had another candy bar and 2 more friends, they each could get 4/8 of the candy bar. So this is one way to show or to see how you can share whole amounts when they're broken into different unit fractions. And we could even write this in a more mathematical way. 1/2 is the same as 2/4, which was also the same as 3/6. So I hope that helps with that problem. I pretty much did the whole thing for you. Maybe this next one, I won't do quite as much of the work for you. In fact, when I looked ahead at this one, the only thing I really wanted to point out on number 3 on the next page is the idea of copies. So this one has it goes back to this language of copies. When the whole is the same, why does it take 6 copies of 1/8 to equal 3 copies of 1/4? Draw a model to support your answer. Well, you could do circle or rectangle or whatever, but I just wanted to make sure you remembered that when we're talking about a copy of 1/8, we're saying like a duplicate of it, or a reprint of it, or another piece of it. So let's see, 1/8 and 4ths, huh? Okay, I'll do this. I'm going to draw them right next to each other because I know we're thinking about explaining equivalency today, and that might help if they're right next to each other. So 1/4, if I split my rectangle into 4ths, is like that. And now they want to know, why does it take 6 copies of 1/8? Well, first let's just get our 1/8 on there. So I'll start by making my 4ths, and then I'm going to split each of my 4ths in half, and that will double the amount of partitions. It doesn't change the size of the whole, it changes the size of the parts. So I have 1/8 and 1/4, and I could label all my units, but they want to know, why does it take 6 copies of 1/8? 1, 2, 3, 4, 5, 6. So that would be all the way down to here. 6 copies. Well, there's 1 copy, 2 copies, 3 copies, 4 copies, 5 copies, 6 copies. And why does it take 6 of these to equal 3 of these? I don't want to give you the answer. I just wanted to make sure you understood that this is just a copy, like a repeat of the same size. This is a copy of this one, and we could continue with our copies. Okay, I hope that helps you out. Let me know if you have any questions. Have a good day, kids.